Today I am going to discuss about the reflection and transmission at normal incidence. Let's suppose we have two media, linear media 1 and 2, and this is the interface between medium 1 and medium 2. This is the z-axis, this is the x, and this is the y-axis. Here, the electric field is along the x-axis, magnetic field is along the y-axis, and z is the propagation direction. To know physically this concept, let's consider this is the z direction, this is the x direction, and this is the y direction. So magnetic field is in this direction, this is the electric field direction, and this is the direction of propagation. And we also consider that this is the interface between these two, these two media. This is the interface. For example, let's suppose this one. This is the interface between these two media, 1 and 2. This is 1 and this is 2. So here the incident wave is propagating along this direction with velocity v1. So this is ei, bi, the incident electric field and incident magnetic field in medium 1. Then some part of this field may be transmitted and some may be reflected. So the transmitted part has some velocity v2 and medium 2, and this is et and bt, and this is the reflected wave v1 with the velocity, and this medium 1, and er is the electric field, and this is the magnetic field and of the reflected wave. Now here we have linear media and xy plane, as I have discussed that this is the xy plane and the wave is propagating along the z direction. A plane wave is propagating in the z direction, having frequency omega. It is polarized in the x direction because the electric field is aligned along the x axis, so it is polarized in along the x direction. Then ei, which is equal to this, and bi, which is equal to this. This is the incident. This is the incident field. And the reflected field must have negative sign. This is the reflected one. Er, which is equal to E naught R, the amplitude, e to the power iota minus k1 z minus omega t. This is the x along the x-axis, and br along the y-axis. And similarly, the transmitted field Et of zt, which is equal to E naught t and k2z, because this is the medium 2, which has k2 is the wave number, and it is along the x-axis, and bt is along the y-axis. It should be noted that the relation between b and e, which is equal to b naught I, which is equal to 1 over v1 e naught I, and br, which is equal to minus 1 over v1 e naught r. This minus comes from this relation because z is equal to minus z, and b naught t, which is equal to 1 over v2 e naught of t. Now we need to find the reflection and transmission at z is equal to 0. At this z is equal to 0, we will apply the boundary condition. There is no component perpendicular to the surface as electromagnetic wave as transverse waves. There is no perpendicular component of the electric field to this plane, because the electric field is parallel to this. So E1 parallel, which is equal to A2 parallel, and E1 parallel here we have incident and reflected. So we can say that E naught I plus E naught R, which is equal to this E naught T. This is E2 parallel. This is the boundary condition, and this is equation number first. The other boundary condition is of the related to the magnetic field, 1 over mu1 b1 parallel, which is equal to 1 over mu2 b2 parallel. And by putting the value of b1 parallel b1, we can say that this term we can apply b1, that 1 over v1 e naught I minus this the negative sign of the reflected 1 over v1 e naught r, which is equal to 1 over mu 2 v2 is the velocity in the region 2. Then we can take v1 common, and e naught I minus e naught r, which is equal to this. And by multiplying this mu1 v1 to the right hand side, then E naught I minus E naught R, which is equal to this, and take this term. Let's suppose this is equal to beta, and beta is equal to mu1 v1 divided by mu2 v2. Then this equation becomes E naught I minus E naught R, which is equal to beta E naught T. This is equation number 2. And now from equation 1 and equation 2, we can calculate the reflection E naught R and E naught T. This is very simple, because this E naught T, putting the value of E naught T from this equation 2 and equation 1, then this E naught T will be equal to 1 over beta E naught I minus E naught R. And putting this in equation number 1, this is very easy. And then multiply beta from this side. And after some mathematical steps, we can calculate E naught R, because E naught is here, E naught is here. Then after some mathematical steps, we can calculate E naught R, which is equal to 1 minus beta divided by 1 plus beta E naught I. And similarly, we can also calculate the E naught T from these two equations. This is not very difficult. So we have E naught T and E naught R. We have these two equations, this one and this one. As for most of the material, mu naught is approximately equal to mu. For most of the material, these are equal. Then one can say that because beta, as we have considered, this is equal to mu1 v1 divided by mu2 v2. For most the cases, mu naught mu1 and mu naught approximately mu2. Then it means that beta will be equal to this will cancel out, and we will have uh, v1 divided by v2. This is the value of beta. Then if we put the value of beta in equation this and this, then this E naught R, which is equal to 1 minus v1 divided by v2, and 1 plus v1 divided by v2, and E naught I, and similarly E naught T, which is equal to 2 divided by 1 plus v1 divided by v2, and E naught I. Here we can take the LCM of this. This is v2 minus v1, and here v2 plus v1 divided by v2, and E naught I. And similarly for this E naught T, which is equal to 2 divided by v2 plus v1 and v2, and E naught I, because V2 as a denominator, then we can write in this form. If we look this equation, then this V2 and this V2 can be cancelled out, and E naught R, which is equal to V2 minus V1 divided by V2 plus V1, E naught I, and here is E naught T, which is equal to 2V2 divided by V2 plus V1 and E naught I. Now, in terms of refractive index, as we know the refractive index, as we know the refractive index n is equal to this, then n1 which is equal to c divided by v1, and n2 which is equal to c divided by v2. From this equation, we can write down V1 which is equal to C divided by N1, and from this equation V2 which is equal to C divided by N2. Now putting the value of V1, V2 in equation this and this. This is a very simple mathematical steps one can write down. Then after some mathematical steps, this n1 minus n2, which is equal to n1 plus n2 E naught I, and this equation E naught T, which is equal to 2n1 divided by n1 plus n2 E naught I. Do this, putting the value of V1, V2 in this and this equation, and you can find out very easily these two equations. Now we are interested to find out the reflection coefficient and transmission coefficient. What is reflection coefficient and what is transmission coefficient? What fraction of the incident field is reflected back to the first medium? This is known as the reflection coefficient. And what fraction of the incident beam is transmitted to the other medium? This is known as the transmission coefficient. So by definition, the reflection coefficient must be equal to IR divided by IR, and the transmission coefficient must be equal to IT divided by II. I is the intensity of light. At what fraction of the intensity of light is reflected and what fraction of the intensity of light is transmitted. This is known as the reflection coefficient and transmission coefficient. And by definition, the intensity 1/2 epsilon naught V E naught square. This is the definition of the intensity. Now, if we define the intensity of incident light, then the incident light II, this will be equal to 1/2 epsilon 1 V1 and E naught I square. And the intensity of the reflected light will be equal to 1/2 epsilon 1 in the first medium, V1 is the velocity in the first medium, and E naught R square. And the transmitted intensity must be equal to 1/2 epsilon 2 V2 E naught T square. So these are the intensities, and now we will put these equation and the reflection and transmission coefficient, and we will find out the R and T. For example, R, which is equal to IR, this is IR 1 over 2 epsilon 1 V1 E naught R square divided by 1 over 2 epsilon 1 V1 E naught I square. Now these terms will cancel out. These cancel out. These terms will cancel out. Sorry. And R, which is equal to E naught R divided by E naught I whole square. Now, what is E naught R and what is E naught I? We are looking to find out the value of E naught R from this equation. If, if I move this E naught I from this side to the left side, then this will become E naught R divided by E naught I, and we will have this N1 minus N2 divided by N1 plus N2. Then we have N1 minus N2, N1 plus N2 whole square. And finally, this R, which is equal to N1 minus N2 and N1 plus N2 whole square. And this is the reflection coefficient. Looking for the transmission coefficient T, IT, this IT 1 over 2 epsilon 2 V2 E naught T square divided by incident 1 over 2 epsilon 1 V1 E naught of I square. Here, this term will cancel out with this, and further, after some mathematical steps and also from this equation E naught T divided by E naught I, this will be equal to 2n divided by n1 plus n2. We can put these terms, and also v1 and v2 we can write down this in terms of refractive index, and after some mathematical steps one can find out 4 n1 n2 divided by n1 plus n2 whole square. The transmission coefficient. Now from the energy conservation, we must looking for the R plus T, which is equal to 1. This is the reflection coefficient and this is the transmission coefficient. And the reflection coefficient and transmission coefficient must be equal to 1. So let's see R plus T. We have R n1 minus n2 whole square divided by n1 plus n2 whole square plus T 4n1 n2 and n1 plus n2 whole square. Now this is a very simple algebra, because we can take n1 plus n2 the LCM, and this term which is equal to n1 square plus n2 square minus 2 n1 n2. I have directly opened this square, n1 square plus n2 square minus 2 n1 n2 plus 4 n1 n2. This is simple LCM, and from this equation n1 square n2 square plus 4n1 n2 minus this will be equal to 2 n1 n2 divided by n1 plus n2 whole square, and this is the square of n1 plus n2 whole square and n1 plus n2 whole square. So this will cancel out, and we have r plus t is equal to 1. So it is true that the reflection coefficient and transmission coefficient, the sum of these two coefficients must be equal to 1.